Alright, 3D printing, it sounds terribly modern, doesn't it? Like something from a science fiction film. But the idea isn't new at all. It actually started bubbling away back in the 1980s. A chap named Chuck Hull, an American inventor, had this rather brilliant idea. What if, instead of carving a block of something down to get a shape, you built it up, layer by glorious layer? He called it stereolithography. It sounds complicated, but the principle is simple. You have a vat of liquid plastic, a UV laser zaps it, and a bit of it turns solid. Do that enough times, and you've made a thing. It was ingenious, but also, let's be honest, a bit of a faff. These early machines were colossal. They were expensive, slow, and smelled a bit funny. You wouldn't find one in your garden shed next to the lawnmower. Then something brilliant happened. Patents started to expire. Around the mid-2000s, some of the core patents on the simpler 3D printing methods, like fused deposition modeling, ran out. This was the moment everything changed. It was like the gates to the sweet shop had been thrown open. Suddenly, clever people all over the world could start tinkering. They could build their own machines, write their own software, and share their designs online. This was the start of the RepRap project, a fantastic idea to create a 3D printer that could print its own parts, a self-replicating machine. How brilliant is that? This open source movement made 3D printers cheap. Well, cheaper. They went from being the price of a decent family car to the price of a fancy television. They started appearing in university labs, small design studios, and eventually, the sheds and spare rooms of enthusiasts. The maker movement was born. People were no longer just consumers of things, they were creators. They were printing everything from replacement knobs for their cookers to intricate models of film characters. It was a glorious explosion of creativity, all fueled by spools of plastic and shared knowledge. The technology had escaped the laboratory. So where are we today? Well, 3D printing is everywhere. It's quietly humming away in the background, making our world better in ways you might not even realize. Take the car industry, for example. Manufacturers are using it to print custom jigs and tools for the assembly line in a matter of hours, not weeks. This saves a colossal amount of time and money. They're also printing lightweight, complex parts for high-performance cars, things that would be impossible to make with traditional methods. Then there's the world of medicine, which is just astonishing. Surgeons are printing exact 3D models of a patient's organs from CT scans. This allows them to plan complex operations and even practice beforehand. Imagine being able to hold a perfect replica of a heart in your hands before you have to operate on the real thing. It's incredible. And it goes further. We now have 3D printed prosthetic limbs that are perfectly customized to the wearer, and they cost a fraction of the old ones. They're even printing custom dental implants and hearing aids. It's personal, precise, and life-changing. And what about space? That's the ultimate engineering challenge. Getting anything into orbit is fantastically expensive. So, what if you could just print what you need up there? That's exactly what's happening. The International Space Station has a 3D printer that can make replacement parts and tools on demand. If an astronaut needs a specific type of spanner, they don't have to wait for the next supply mission. They can just print one. This is a game changer for long-duration space travel, making missions to Mars and beyond seem that little bit more plausible. Right then, you're an engineer, you solve problems, you make things work. So, why should you care about this plastic squeezing box? Because it fundamentally changes the rules of the game. For your entire career, you've likely been trained to think in terms of what can be milled, cast, or welded. Your designs have been constrained by the limitations of traditional manufacturing. 3D printing throws that rulebook out of the window. With additive manufacturing, complexity is free. A simple solid cube costs about the same to print as an incredibly intricate hollow lattice structure of the same size. Let that sink in for a moment. All those brilliant, efficient, lightweight designs you've had in your head, the ones that were impossible to make, are now possible. You can design parts that are optimized for strength and weight, not for the convenience of a milling machine. This technology also accelerates your workflow at a blistering pace. With a 3D printer on your desk, you can design a part in the morning, print it over lunch, and be testing it in the afternoon. This rapid iteration means you can fail faster, learn quicker, and arrive at a better solution in a fraction of the time. It allows you to hold your ideas in your hand almost as fast as you can think of them. So, what's next on the horizon? Well, it's all going to get faster, bigger, and a lot more clever. New technologies are being developed that promise to increase printing speeds by a factor of 100. Imagine printing a complex component in minutes instead of hours. The factory of the future might not have assembly lines, but rows of silent, incredibly fast printers. The materials science is where things get really exciting. Scientists are working on 4D printing. This is where you print an object that can change its shape or properties over time when exposed to a stimulus, like heat, light, or water. We're also seeing huge advances in bioprinting, using living cells as the ink to print tissues and, one day, perhaps entire organs for transplantation. It's mind-boggling stuff. We'll also see manufacturing become much more distributed. Instead of huge, centralized factories, you could have a network of smaller, local printing hubs. Need a spare part for your dishwasher? The design file is sent to your local print shop and you can pick it up the same day. This would slash shipping costs, reduce waste, and make supply chains much more resilient. It's a more sustainable and efficient model for making the things we need. Looking back, the journey from Chuck Hull's clunky machine to the advanced systems of today has been extraordinary. But it feels like we're still just at the beginning. As engineers, you are the ones who will drive this technology forward. You will be the ones who imagine these self-assembling structures, design these on-demand parts, and solve problems we haven't even thought of yet. The future of 3D printing isn't just about better printers, it's about a fundamental change in how we create, innovate, and build our world. All I can say is, you'd better get a bigger shed. You're going to need it.